Only grade 11 theorems. Okay, let's start with this analytical geometry revision. One question. Before you start any chapter, you must know the formulas. Formulas will not be given to you. Make a mistake in the formula, no marks. Okay, so let's start with grade 9. What formula we had in grade 9 about analytical geometry? Gradient. So gradient m is equals to y2 minus y1 over x2 minus x1. Okay, now gradient is related to two type of lines. One is parallel and the other one is perpendicular. Right. So, what is the condition for parallel lines?
M1 is equal to M2.
Right, so M1 is equals to M2. And what about the perpendicular lines? M1 times M2 equals to minus 1. So if they give me already perpendicular, right, I'll multiply one of them and the second gradient we will get it. Okay. Then what is the other formula? Midpoint. Midpoint is capital M. Huh? It's x1 plus x2 divided by 2 and y1 plus y2 divided by 2. That's the midpoint. Okay. Then the next one is the distance. What's the distance formula? Square root of y2 minus y1 squared plus x2 minus x1 squared. Then that's all. Okay. Finding the equation of a line. Finding the equation of a line, we say y is equals to mx plus c. So your job is to find out the gradient. So that the first step number 1 is find the gradient. And let's say you found a gradient which says m equals to half, just for the example. Right? Your second job is to find out, second step is to find out c. To find out c, only c must be unknown, isn't it? It means in your second step, you have to substitute a point which has got the x coordinate and y coordinate. Because gradient you already have it, found it, it's half. Now if you substitute a point, you will be left with only c. Okay, the moment you find m and c, your job is done. So y equals to half x plus 12 or half x minus 2, anything. Right, only those formulas are there. Let's go to our question then. Right, okay, with that one, in this chapter you are going to have some words, especially parallelogram. What do we know about parallelogram from grade 9 and grade 10? What do we know? Parallelogram. It was there in grade 9 also. Right, let's start with, okay, this is my parallelogram. Let's start with the first. The word itself, it says, what is it?
Parallel.
Parallel. So opposite sides are parallel. So the moment there is a word parallelogram, I can say M1 equals to M2. Then, number 1. Other side is also parallel. What else still on the side? Opposite sides are also equal. The other side, other pair is also equal. That's number 2. About the sides. Parallel and equal. What about opposite angles?
They are equal.
They are equal. They are going to be equal. Both the pairs. Okay. And in analytical geometry, most important about this word in this chapter is
Bisect.
diagonal bisect. So that means that point where the diagonals meet, that will be the common midpoint for both the diagonals. Right? So A, B, C, D. M is a midpoint of AC. At the same time, M is a midpoint of BD as well. Okay, diagonal bisect. So that means this two BD will be bisected into two equal parts, B to M and M to D. That's why M will be the midpoint. At the same time, AM will be equals to MC. Very important. These words will come. Okay. Then go back to the other diagrams, parallelogram. Then tell me rhombus. What do you know about rhombus? What do you know about rhombus? All sides equal. In parallelogram, only opposite pairs are equal. When it comes to rhombus, all sides are equal. Okay. Something specific. Okay, this is the first major difference between the parallelogram and the rhombus. Okay. One more major thing I want to know from you related to diagonals. Let me be more specific. Right. So diagonals bisect each other. That's true, the same as the previous one, but they will meet each other at 90 degrees in the center. That's the most important. The moment we have a 90 degree, two or three things are possible. It gives you right angle triangle. Am I right? So the moment you have a right angle triangle, when it comes to calculation, Pythagoras, because Pythagoras works with a right angle triangle. Number two, Number two, it works with SOHCAHTOA. And number three, it works with the perpendicular line, isn't it? 90 degrees, that means two lines are perpendicular each other. That means the third kind of calculation possible is M1 times M2 equals to minus 1. Very important. Okay. Right. Which other quadrilaterals, diagonals meet at 90 degree? The other important is kite. Diagonals, they will meet at 90 degree. Kite. Then another one is the square. The diagonals will meet at 90 degree in a square. So this knowledge you need to have to get a good marks. Okay, let's go to our question now. All right, so we go. Right. So the method is whatever you read, observe. Okay. So if I say in the diagram below, A is 2 and 5. Where is it? Okay, there is it. If it is not given, if it is given in reading, but it's not given on the diagram, you must put it in. Number 2, B is minus 2 and 7. Minus 2 and 7. C is minus 4 and 3. Okay, that's it. D is 0 and 1. Are the vertices of quadrilateral. So far we don't know whether it is a parallelogram, rhombus, square, kite. We don't know. It's just quadrilateral. It has got 4 sides. Okay. Let's go to the questions now. 6.1. Calculate the length of BD. Where is BD? Okay, so that's a diagonal. That's a distance formula we are going to use. Okay, so let me work here. 6.1. Can we substitute the formula? Distance is equals to square root of y2 minus y1 squared plus x2 minus x1 squared. Right. Which 2 points we are talking about? So what will I do? I will write those 2 coordinates next to each other, top and bottom. It is not compulsory, but I will make it a habit that I will write those 2 points there. Why? Because when I want to substitute y2 minus y1, I will just substitute straight. Right? Those two coordinates are y. Right? Doesn't matter which one is y2, which one is y1. Right? So square roots 7 minus 1 square plus minus 2 minus 0 square. Use your calculator. Give me answer. So my answer for this is what? 2, 2 root 10 or root 40. Root 40. Square root of 40. Yeah. Alright. So this 6.1. Answer we got 3 marks. 6.2. What is that 6.2? Show that AC equals to BD. BD we already have it. So my job is to find out the length of AC and see are they equal or not. Show that it means most probably it will be the same answer. If I don't get the same answer, I must go and look for my mistake. So 6.2, distance AC. So square root of, okay, so A. What are the coordinates of A? 2 and 5. C is minus 4 and 3. So I'll say y2, which is 5, minus y1 squared. That's y2 minus y1, green line. Okay, then x2 minus x1, 2 minus minus 4, plus 2 minus minus 4 squared. Okay, it will, your calculator will convert it. And let's get, give me the answer. 2 root 10. Therefore, AC equals to BD. That's it, done. Okay. Okay, so the next question is show that the coordinates of M, midpoint. When they say show that, they're giving you answer. You need to reach that answer. Okay. If you don't get that answer, you have a second chance to correct it. Right? So in short, the question which is show that, that's the easier. Right. Okay. What's the formula for midpoint? 6.3 now. Midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Which two coordinates we are talking about? No. Is it BD? Okay, BD. We already have those two coordinates. B is minus 2 and 7 and D is how much? 0 and 1. Is it B and D? We are looking for a midpoint here. Okay. So, let me start with it. So here, x1 plus x2. Can you see it's easier if we write it top and bottom. So it is minus 2 plus 0 divided by 2 and yellow color y1 plus y2 divided by 2. So it's 7 plus 1 divided by 2. If I use a calculator, that's minus 1. 7 plus 1, 8 divided by 2 is 4. Got it. Done. Simple. Right. Next question, 6.4. Gradient of AN. They are giving you specific word. So I will say, start with the formula 6.4 small m of AM. Right. So y2 minus y1 over x2 minus x1. Then I will write down those two coordinates. What is A? 2 and 5. And M we got just now. Minus 1 and 4. So that's y2 minus y1. 5 minus 4. x2 minus x1. 2 minus minus 1. Okay, what's my answer?
When you say x2 minus x1, so it's minus 1 minus 2.
y2 minus y1, we started this way.
Oh,
And x2 minus x1, we start this way. Same. Right? So it is 1 over 2. 1 over 3. Okay. Let's change it to 1 over 3. Okay. Marks. 6.5. Prove that AM perpendicular to BD. Right? So what do we know about the perpendicular then? I calculate the gradient of one line. I calculate the gradient of another line. And I see, is it minus 1 or not?
yeah.
So which two lines they are talking about? AM. So the gradient of AM, which we already have it, how much? 1 over 3. Gradient of M2, which is BD, do we have it? No. So what I'll do, I'll calculate it on a side. So it's again y2 minus y1 divided by x2 minus x1. Isn't it? Okay. So let me write down the coordinates on a side. B is what? Minus 2 and 7. And D is 0 and 1. Okay. So y2 minus y1, that's 7 minus 1. x2 minus x1, that's minus 2 minus 0. What's the calculator answer? Minus 3. That minus 3, I'll take it here, substitute. Is my multiplication minus 1?
Yeah.
Therefore, AM, where the gradient is, perpendicular to BD. Okay. Then I go to the diagram there, AM. So I'll join it now. And it's perpendicular. Isn't it? Okay. So whatever answer I get, I'm going to use it in the next question. Right? Be careful there. So analytical geometry questions, most of the time they are structured. Okay. So what I got here, I must go and mark. What are my coordinates of M? Minus 1 and 4. Right. 6.6 now. Write down giving reason what type of quadrilateral. So I got diagonals, they meet at 90 degree now. So either I have a square or a rhombus or a kite. Okay. So previous answer might also help me. 6.6. Okay. That's 90 degree. Do I have the gradients or how do we decide what is it? Previously in this question, AC. What is AC? It's a diagonal, isn't it? Is equals to BD. That's the second part they are giving me. We proved it. In which diagram my diagonals are equal? That's rhombus. We did draw all that. So that's one diagonal. That's another diagonal. Do they look like the same size?
Yeah.
Now, if I use a ruler, the first diagonal, if I start with this ruler, is 1, 2, say it's 2 centimeter. If I use my ruler here, it says 2 centimeter. If I use this, it says 1.5 centimeter. Do I have the same diagonal? So it is 1.5 centimeter. Okay, so my diagonals are not equal here. So it is definitely it's not rhombus. Right. And in kite, it's straightforward. Clearly seen. One diagonal is small, the other diagonal is very big. Okay, so it is not a kite also. Right. So what are we left with then? Square. In the square, the diagonals are equal. Right? So I will say my reason square. Answer is square. What is the reason? Diagonal AC equals to BD. Diagonals equal. And diagonals equal only in one condition, it's rhombus. Together with if there is a 90 degree in the center, which we have it. Okay? Alright. I'm going to ask you a few more questions which are not here. Right? Or rather, I'm going to show you something extra related to this diagram. Okay, so be careful here. Let me clean up my screen here. Okay. Do we have a gradient, the midpoint of this two in this question? What is our midpoint they give me? Minus 1 and 4. Let's say I don't have a coordinates of A. Both the coordinates are unknown. Both the coordinates are unknown. How do we get that answer now? We know in parallelogram, let's say this question, they say it is not a quadrilateral, they say it is a parallelogram. Okay, and in parallelogram, let's say coordinates of A are unknown, both the coordinates. How do we get? And it is only 2 marks. Okay, so we are going to use the property of parallelogram. Midpoint is the same. Whatever is the coordinate, whatever is the midpoint of BD, that's the known one, from where we get the coordinates of M, that M, I'm going to use it to link A and C. Right? So it is going to be observation method. Right? I'm going to link X coordinates first. Okay, let's say minus 4 to minus 1. How much is the distance? Count it on your finger. Minus 4 to minus 1. 3 units. Up or down? Up. So from minus 1, 3 units up? 2. And isn't it we had 2? Let's link Y now. 3 to 4. How many units? 1. So 4 to how many units? How 4 to 1 more unit? 5. We got the coordinates. Isn't it? Is it understandable? Okay. Let's say we don't have the midpoint also. Right? And I have only 3 coordinates. B, C, and D. And the word there is a parallelogram. What do we know about a parallelogram? Opposite sides are equal. Isn't it? So that is what I'm going to use. Right? I'm again going to compare X coordinate of one side, and then I'm going to use that comparison to the other side. Right. Let's say minus 4 to minus 2. How many units? How many units? 2 units up. So from 0, 2 units up. 2. 3 to 7. How many units up? 4 units. So 1 and 4 more units.
5. Wow.
Okay. So this is what we can do. If I don't want to use this side, I can use the other side as well. From minus 4 to 0, X coordinates. 4 units down. 4 units up, sorry, you are right there. So from minus 2, 4 units up, 2. From 3 to 1, 2 units down. So from 7, 2 units down.
5.
Okay, so this one is going to work with the word parallelogram. Okay, and so I will